One way to fix wrong values is to replace them with something else. In our example, it's most likely a typo and the value should be 45 instead of 450, and we just could not insert 45 in a row 7. Example, set duration is equal to 45 in row 7, df.loc within square braces 7 comma duration is equal to 45. For small data sets, you might be able to replace the wrong data one by one, but not for big data sets. To replace wrong data for larger data sets, so you can create some rules. Example, set some boundaries for legal values and replace any values that are outside of the boundaries. Example, loop through all values in the duration column. If the value is higher than 120, set it to 120. For x in df.index, if df.loc within square braces x comma duration is greater than 120, df.loc within square braces x comma duration is equal to 120. Removing rows. Another way of handling wrong data is to remove the rows that contains wrong data. This way you do not have to find out what to replace them with, and there is good chance you need to do with your analysis. Example, delete rows when the duration is higher than 120. For x in df.index, if df.loc within square braces of x comma duration is greater than 120, df.drop within x within braces x comma in place is equal to true. Pandas and removing duplicates. Discovering duplicates. Duplicate rows are that have been registered more than one times. So refer this data set, and there is some duplicates in this, and we are going to be removing them. By taking a look at our test data set, we can assume that row 11 and 12 are duplicates. So 11 and 12 are duplicates. To discover duplicates, we can use the duplicated method. The duplicated method returns a boolean values for each row. Example, returns true for every row that is duplicate, otherwise false. Print df.duplicated. Removing duplicated. To remove duplicates, use drop underscore duplicates method. Example, remove all duplicates. df.drop underscore duplicates in place is equal to true. Pandas in data correlations. Finding relationships. A great aspect of pandas module is the car method. The car method calculates the relationship between each column in your dataset. The examples in this page uses a CSV file called data.csv. So download data.csv or open data.csv. Example, show the relationship between columns. df.co. So result will be duration, pulse, max pulse, calories, duration 120.155408, pulse is equal to minus 0.155408, 1008, 1.000, and max pulse 0.0009, 403, 0.786535, 1.00000, 0.203814, calories 0.92271, and goes on. Note, the car method ignores not numeric columns. Results explained. The result of the car method is a table with a lot numbers that represents how well the relationship is between two columns. The numbers varies from -1 to 1 as we seen in the above result. 1 means there is a 1-to-1 relationship, a perfect correlation, and for this dataset, each time a value went up in the first column, the other one went up as well. 0.9 is also a good relationship, and if you increase one value, the other will probably increase as well. Minus 0.9 would be just as a good relationship as 0.9, but if you increase one value, the other will probably go down. 0.2 means not a good relationship, meaning that if one value goes up, does not mean that other will. What is a good correlation? It depends upon the use, but I think it's safe to say you have to have at least 0.6 or minus 0.6 to call it good correlation. Perfect correlation. We can see that duration got the number 1.00000, which makes a sense. Each column always have a perfect relationship with itself. good correlation. Duration